Hi guys, welcome to Managerial Economics. So now, we will tackle some of the chapters here in this book, chapters 4, 5, and 6. Exercise 4-3. It is all about insourcing sales force. The problem is, 5 years ago, to respond to cost-cutting pressure during a weak economy, your company decided to close 5 sales offices, employing 5 people each. Currently, your company employs independent sales agents who earn a 2.5% commission on all sales. The economy has recently turned around, and one of our colleagues suggests that you could hire 25 people for $50,000 per employee to do the sales job as independent agents at a cost of goods sold or COGS of only 0.5%. The question is, what concerns might you have about such an approach? Our concern about the approach on insourcing sales is that the possibility that the economy in some future time will become weak. And if this happened, the company again will have to respond to cost-cutting pressure by having employee layoffs. Therefore, it is better that the company would just continue outsourcing sales force that is being paid by 2.5% commission on all sales. And we think that the compensation scheme on this outsourced sales force is better because it is based on the amount of sales, thereby encouraging these outsourced sales force to work harder because they can get greater income if sales are high. They can benefit in this way, at the same time, it's beneficial to the company. Next, exercise 4-4. It is all about the copier company. So the problem is this. A copy company wants to expand production. It currently has 20 workers who share 8 copiers. 2 months ago, the firm added 2 copiers and output increased by 100,000 pages per day. 1 month ago, they added 5 workers and productivity also increased by 50,000 pages per day. Copiers cost about twice as much as workers. Would you recommend they hire another employee or buy another copier? Stated in the problem, the copier's cost is about twice as much as workers. Let's assume that the worker's price is $1. Therefore, the copier's price is $2. In order for us to know which is beneficial between to hire another employee or to buy another copier, let's compute first the marginal per labor and the marginal price per copier. In the marginal price per labor, there are 50,000 additional pages divided by 5 workers equals to 10,000 pages per worker. Thus, per $1 spent, we can produce 10,000 pages. While in marginal price per copier, there are 100,000 additional pages divided by 2 copiers equals to 50,000 pages per copier. Thus, per $2 spent, we can produce 50,000 pages. So, per $1 spent, we can produce 25,000 pages. Therefore, we would recommend that the company should purchase another copier because it can produce more than hiring another employee. Next, exercise 4-5. It is all about incentive pay. A company recently raised the pay of workers by 20%, yet workers' productivity did not improve. Example, they produced the same amount and quality as before. Why? Next, exercise 4-5. It is all about incentive pay. A company recently raised the pay of workers by 20%, yet workers' productivity did not improve. Example, they produced the same amount and quality as before. Why? Workers' productivity did not improve even if the company raised the pay of workers by 20%, because the incentive scheme did not push the workers to exert more effort. Therefore, we recommend companies should change their incentive scheme that encourages workers to work hard. For example, giving them incentives if there is a 5% increase in sales. So now, let's tackle some of the exercises in Chapter 5. Exercise 5-1, it is all about printer holdup. The problem is, suppose that in our National Geographic example, half of the original cost of the rotogravure printing press is fixed and half is sunk. How low can the offered price go before the printer will rationally refuse to print magazines? So, what is asked here is the break-even price. Given in this problem, our fixed cost is $12 million, units 2 million, and our marginal cost is $1 per unit. It is said to be that half of the original cost of the rotogravure printing press is fixed and half is sunk. So the break-even price is the average avoidable cost per unit. Since the sunk cost is unavoidable, we will use the fixed cost of $12 million, which will be divided by 2 because it is stated in the problem that sunk cost is just half of the original cost of the rotogravure printing press, which would give us a result of 6 million. Our break-even price formula is fixed cost divided by the units plus marginal cost. Our fixed cost here is $6 million divided by the 2 million units plus our marginal cost of $1 per unit. So it will give us a result of $4 per unit. Exercise 5-2. It is all about original equipment manufacturer hold up. The problem is, suppose you work for an original equipment manufacturer or OEM who makes components for a telecommunications company. The telecom company asks you for a price quote 2 million units that will require a $1 million investment with marginal cost of $1. What is your bottom line in negotiations with a telecom? Suppose you agree on a price slightly above your bottom line. Immediately, quoting this price to the telecom company, you receive a fax purchase order for 1 million units. What should you do? Given the problem, our fixed cost is $1 million investment, units 2 million, and our marginal cost is $1. The formula for break-even price is equals to fixed cost over units plus marginal cost. So the $1 million investment is our fixed cost divided by the 2 million units plus 1, which is our marginal cost, is equals to $1.5. Therefore, price should be slightly above $1.5. After quoting this price to the telecom company, you receive a purchase order for 1 million units. So let's use again the formula of the break-even price. So our fixed cost is 1 million over or divided by 1 million units plus $1 is equals to $2. To answer the question in this exercise, we should renegotiate and accept purchase order for 1 million if the price is increased to slightly above the new bottom line of $2. After the investment of $1 million, it will now be a sunk cost, which is an unavoidable cost. The break-even price will fall to the marginal cost of $1. If the telecom company decides to order 1 million units, the price can now be adjusted to slightly above $1 since the fixed cost was already covered by the previous $2 price. Next, 5-4, it is all about pet store. The problem is a local pet store, Roscoe's Rascals, which has concentrated on selling puppies, is considering adding a line of pet food. A contractor estimates that it will cost $10,000 to convert some storage space into a retail area for the food. Roscoe's Rascals will purchase the specialty food for $15 and sell it for $30. Marketing research indicates that the store will sell 900 bags. Should Roscoe's Rascals add pet food to its products? Given this problem, our fixed cost is $10,000, our marginal cost is $15, and the price is $30. So we will use the formula of break-even quantity, which is fixed divided by the price minus marginal cost. So our fixed cost is $10,000 divided by $30 minus $15, which will give us 667. Therefore, Roscoe's Rascals should add pet food to its products because the sale of 900 units is greater than the break-even quantity of 667. The alternative solution is our sales, 900 bags, multiplied by $30, which is the price, is equals to $27,000. Our cost of goods sold here is 900 bags multiplied by $15, which would give us $13,500. So our gross profit here is $13,500. Our fixed cost, which is given in the problem, amounted to $10,000. So our net income is $3,000. So now let's tackle the exercises in Chapter 6. Exercise 6-1. It is all about optimal pricing for an aggregate demand curve. The problem is, suppose you have 10 individuals with values of $1, $2, $3, $4, $5, $6, $7, $8, $9, and $10. Your marginal cost reduction is $2.50. What is the profit maximizing price? As you can see in the table, at a price of $10, one consumer would purchase. So revenue would be $10. Cost would be $2.50. So profit on the first sale would be $7.50. If we reduce price to $9, two consumers will purchase. So revenue goes up to $18 and would give us an increase of $8, and so on. So at the price of $7, revenue would be $28, less the marginal cost of $10, wherein we will get a profit of $18. Therefore, the profit maximizing price is 7 at a quantity of 4. Exercise 6-2. It is all about what about fixed cost. The problem is, using information from the question 6-1, your boss tells you that price cannot drop below $9 because you cannot earn enough profit to cover your fixed cost. What should you tell her? So in pricing, you should base it on marginal analysis, not average analysis. And also, fixed costs will always be incurred, no matter how many quantity you produce or sell. Therefore, it should not affect in making decision because it is already a sunk cost. Now, exercise 6-3. It is all about pricing ATM machines. The problem is, a bank in a medium-sized Midwestern city, Firm X, currently charges $1 per transaction at its ATMs. To determine whether to raise price, the bank managers experimented a number of higher prices, which is in 25 cents increments, at selected ATMs. The marginal cost of an ATM transaction is 50 cents. As you can see in the table, the ATM fee in the first row is $2 and the usage is 1,000 and so on. So the question is, what ATM fee should the bank charge? So at a rate of $1.75 with a marginal cost of 50 cents, there is a net of $1.25. We multiply it by the usage of 1,500, we will eventually get, or we will get the result of a total fee of $1,875. At the rate of $1.50, there is a revenue of 2,000. Therefore, the bank should charge at the rate of $1.50.